Hi, my name is Eric, and welcome back to Sci-Inspiration. This is the second in a series of 2 videos on the science behind space travel and science fiction. So if you haven't watched the first video yet, click the annotation in the corner or find the link in the description below. In the first video, we explored some of the fastest speeds humans have ever achieved and how they fall far short of letting us travel between the stars. In that video, we also took a look at the laws of physics that prevent us from accelerating beyond the speed of light. In short, Einstein's theory of relativity shows that there is an inherent speed limit to the universe, that objects cannot travel faster than the speed of light. But if speed is limited by the laws of physics, then how does space travel in Star Trek, Star Wars, and Elite Dangerous work? This is where some more theoretical technology comes into play. It turns out that the frameshift drive in Elite Dangerous draws inspiration from both Star Trek's warp drive and Star Wars' hyperdrive. While we're making our way out of the starport here, there's one more concept I want to introduce before talking about superluminal travel, or faster than light travel, and that is the concept of spacetime. Spacetime is just the joining of space and time into a single entity. Each of these ideas is simple on its own. Space describes where something is, and time describes when something is. Spacetime, then, is just a way of describing both where and when something is. As humans, we can see where things are in 3 dimensions: height, width, and depth. But when it comes to seeing when things are, we can only see one time, and that's now.
There's no now. Everything is the near future or the recent past.
Actually, now.
There's no present. Welcome to the present. Gone again.
Now?
You're looking at now, sir. Everything that happens now is happening now.
What happened to then?
We passed then.
When?
Just now.
Now.
Go back to then.
When?
Now.
Now?
Now.
I can't.
Why?
We missed it.
When?
Just now.
When will then be now?
Soon.
Anyway, compare this to the Tralfamadorians from Kurt Vonnegut's Slaughterhouse-Five, creatures which could see in 4 dimensions, and pitied Earthlings for their ability to only see 3. On what it's like to see in 4 dimensions, Vonnegut writes, "As a Tralfamadorian, we see all time as you might see a stretch of the Rocky Mountains." For this video, we just need to think of spacetime as being a set of 4 coordinates that describes where and when something is. Now that we have that down, let's talk about Star Trek's warp drive. Instead of a ship flying around in space in 3 dimensions, it'll be easier to picture things 1 dimension lower, in the 2nd dimension. Let's imagine a miniature car driving on a piece of paper. If this car was driving as fast as it could, it would take 10 seconds to drive from point A to point B. Nothing we do will make this car drive any faster. So how can we get to point B in under 10 seconds? An easy way to do this is to fold the paper. If we fold the paper in half, then build a bridge between the 2 points, we can make it to point B in far less time. This is essentially how the warp drive in Star Trek works. By pulling together 2 separate points in spacetime and traveling directly between these points, starships can make long-distance journeys in a fraction of the time. This higher dimension that the starship travels through, the bridge outside of the paper, is called subspace. At least, that's what Star Trek calls it, but it turns out to just be another case of technobabble. Technically, this bridge would be in hyperspace, which may or may not be related to the hyperspace in Star Wars, which we'll talk about a bit later. Star Trek the original series first debuted in 1966. However, it wasn't until 28 years later that physics was able to propose a working theory for the warp drive, when Mexican theoretical physicist Miguel Alcubierre proposed his idea for superluminal travel, the Alcubierre drive. And while the Alcubierre drive does draw its inspiration directly from Star Trek, it operates very differently. If we go back to our car example, it turns out it's not easy to build a bridge between 2 points in spacetime, but the paper itself is pretty easy to warp and bend. If we bend the paper down in the front and up in the back, the car will roll from A to B on its own without needing to use any energy to drive the wheels. This is more or less how the Alcubierre drive operates. By warping space-time around the ship, The Alcubierre drive creates a sort of wave that the starship just surfs to its destination. It accomplishes this by creating a bubble around the ship, then moving mass from the front to the back of the bubble. Just like drinking water through a straw, removing the mass in front of the bubble pulls it forward. And while the ship doesn't move faster than the speed of light within the space-time bubble, the bubble itself can achieve superluminal travel. Interestingly, because the ship isn't moving relative to its surroundings, a traveler wouldn't actually experience any acceleration at all. The space-time around them is moving, but to them, inside their bubble, they're stationary. So how does Elite Dangerous fit into all of this? The frameshift drive in Elite Dangerous consists of two modes: Supercruise and Hyperspace. According to the game's lore, Supercruise uses a modified Alcubierre drive. It still warps space-time like the Alcubierre drive does, but in a slightly different way. Going back to our car example, Supercruise works by crumpling the paper in front of the car. The car still drives forward at the same speed, but it crosses a much larger distance in the same amount of time. Then it simply uncrumples the paper behind the car. In terms of our spaceship, Supercruise just compresses the space-time immediately in front of the ship and expands the space-time immediately behind the ship, while once again protecting the ship itself in a space-time bubble. Aside from how they warp space-time, the other difference between Supercruise and the Alcubierre drive is that you still experience acceleration with Supercruise. The ship still has to propel itself forward, unlike the Alcubierre drive. In Elite Dangerous, Supercruise is used to explore within a solar system, but traveling to a neighboring solar system requires the use of the frameshift drive's second mode, Hyperspace. It turns out that both Elite Dangerous's hyperdrive and Star Wars' hyperdrive function in about the same way. That is to say, neither has a strong basis in science. There has been a lot of debate over how these hyperdrives work, but the consensus seems to be that the hyperdrive travels between points in our space-time by creating a path in a separate, parallel space-time. Think of this like driving a car on a two-lane highway. The car starts in the right lane, which has a speed limit of c, the speed of light. If you are in this lane, you cannot travel faster than the speed of light. However, the left lane doesn't have a speed limit. Well, it actually does have a speed limit, a lower limit. In this lane, everything must travel at least the speed of light, no slower. In order for the car to reach its destination faster, it just has to jump into the left lane and floor it until it nears its destination, then drop back out into the right lane. This is essentially how the hyperdrive works. The right lane is our spacetime and is comprised of baryonic matter, matter that can't exceed the speed of light. The left lane is a separate, parallel spacetime that we would call hyperspace. Because everything in hyperspace must travel faster than the speed of light, it can't be made of baryonic matter. Instead, this parallel spacetime is comprised of tachyonic matter. These two different types of matter can't coexist, so to switch between our spacetime and hyperspace, the hyperdrive envelops the ship in a bubble of baryonic matter that blends with the surrounding tachyonic field until the ship reaches its destination. Like I said before, this theory of superluminal travel is entirely fictional and currently doesn't really have any scientific backing. But that hasn't stopped science fiction before. And who knows, just like how Star Trek inspired the design of the Alcubierre drive, maybe one day the hyperdrive will inspire the design of some other futuristic technology. Sadly, it will be a long time before science is able to turn this fiction into a reality. Until then, we will continue to explore the cosmos with our 2 feet planted firmly on the Earth beneath us. However, while the Earth may be the cradle of the mind, we cannot forever live in a cradle. Hey, thank you so much for watching. I want to give a huge shout out to Commander DiCello from the Elite Dangerous forums, who wrote an incredibly in-depth post explaining a lot of the science behind Elite Dangerous, covering everything from the flight suits to the space stations and everything in between. A lot of my understanding of the science behind the frameshift drive comes directly from him, so if you want to learn more, I will leave a link to the post in the description below. This episode's science shoutout goes to PBS Spacetime. If you love astrophysics, go check out their channel. In particular, Matt has a fantastic video about the Alcubierre drive that goes into way more detail than I could go into here. Click here to check it out, and I'll include a link to the channel below. There are a ton of other fictional technologies for faster than light travel out there, so I want to hear from you. If you have a favorite space travel technology, share it down in the comments below. If you enjoyed this video, please give it a like, and if you want to learn more science from your favorite popular media, go ahead and click that subscribe button. Until next time, stay inspired.